everybody, and welcome to this video on mixed sequences and series. In this video, we're having a look at even more examples. So over here, we're finding the nth and 100th term. So the nth term is just another way of asking for the general formula. So we would like the general formula and the 100th term. So please pause the video and attempt this by yourself before we do it together. And let's get started with the first one. So we have 5, 10, 20. So we have to determine what type of sequence it is. So I'm going to look for a geometric, so divide. So 10 divided by 5 is 2, and 20 divided by 10 is 2. So it has a common ratio. So that means it is geometric. Okay, so now we can use the formula Tn is equal to a to the power of Rn minus 1. We would like to substitute the a and the r. So the a is the first term and the r is the common ratio. So this here becomes 5 times 2 to the power of n minus 1. And then what we have is Tn is equal, we can leave it as 5 times 2 to the power of n minus 1 if you'd like. Then to calculate the 100th term, we then just substitute 100, so 2 to the power of 100 minus 1, so it's 5 times 2 to the power of 99. We'll leave it in that form because that exponent is quite big. Okay, let us have a look at the second one. So the second one over there, we have the question 1, 8, 27, 64, 125, and so on. Now, let's look for a ratio. So 8 divided by 1 is 8, 27 divided by 8, 64 divided by 27, 125 divided by 64. So it looks like there's no common ratio over there. So let us then look for a difference. So 8 minus 1 is 7. 27 minus 8 is 19. 64 minus 27 is 37. And 125 minus 64 is 61. So we have no common first difference, so it's not linear. So it's not geometric, because there's no common ratio. It is not linear because there's no common first difference. Let's look at our second differences. So 19 minus 7 is 12. 37 minus 19 is 18. And finally, 61 minus 37 is 24. So again, there's no common second difference, so it's not quadratic. So then we have a look at the third differences. So your 18 minus 12 is 6, and 24 minus 18 is 6. So this here is then a cubic pattern because it has a common third difference. A common third difference. So then what we're going to do is then we're going to find the general formula. So the general formula, we then substitute we look for what pattern. So if you have a look at it, 1, 8, 27, 64, and 125 are all perfect cubes. So if you look at that, then the pattern would be Tn is equal to n cubed. So then what we have is, that's our general formula, and to get the 100th term, then it is just 100 to the power of 3. So then that would be equal to 10 million or million. Okay, so yeah, a million. Okay, so let us have a look at the next example. So we have, the next one is 0.5, 1, and 1.5. So we can first again look for the common ratio. So we have that 1 minus 0.5, 1 divided by 0.5 is 2, and then 1.5 divided by 1, and this should be 1.5. 1.5 divided by 1 is 3 over 2. So here we don't have a common ratio, so it is not geometric. So then we can have a look at common differences. So 1 minus a half is a half, and 1.5 minus 1 is a half. So it has a common first difference, so it is linear. So if it is linear, it follows the general formula Tn is equal to A plus n minus 1 times D. So we have that Tn is what we're going to get the general formula, or the nth term. A is the first term, which is 0.5, plus n minus 1 times our common difference, which is also a half, or 0.5. So then solving for this, we get distribute that, so a half n minus a half. The halves cancel out, so we have that Tn is a half n. So the last one we have to do for this question is calculate T100. So T100 is then substituting 100 in the formula, so a half of 100 is then 50. I hope that you have understood these examples. If you have not, please watch our previous videos, and thank you for watching. Bye.